Equivalent trigonometric expressions, 4.3. So I'm gonna do this one on another blank pages. So you don't need to memorize anything here. As we did talk about before, if you have a unit circle, okay, you have a unit circle here. Any point on the unit circle, it has X and Y, right? If I just connect from the center to that point, so you have an angle here. From here to here is your Y component, and from here to here is your X component. And since this is unit circle, the radius of the circle is 1, means the hypotenuse of this right angle triangle is 1. Sine theta is equal to opposite over hypotenuse is just y over 1, which is y. Cosine theta is equal to adjacent over hypotenuse is x. Tan theta is equal to opposite over adjacent is y over x. So this is what you have. Now this is about the transformation. Let's just do the transformation by 180 degree. This is a transformation by 180 degree. See? If I have that and I transfer it, I rotate this by 180 degree, it will be here, right? Just rotate it by 180 degree, it come here. And this theta is the same. But here your y component, now become negative, right? And now your x component is negative as well. So what is happening? You have the same triangle, but different. Okay, I'm gonna just write down that for you so you understand better. Another pen. Okay. Let's say I want to find sine of theta plus pi. Pi is 180 degree. I have the same triangle, right? Exactly the same. My x component is a negative x, my y component is just negative. The sign is different. Since you are in this quadrant, according to the Chast rule, tangent here is just positive. So sine theta plus pi is equal to sine of theta. But positive or negative? Negative, because in this quadrant, the sign is negative. Cosine, can you tell me what is the cosine of theta plus pi? What do you say? It's equal to what, do you think? Is equal to cosine of theta. Do you think it's going to be positive or negative?
Positive.
So cosine, so here is just Chast rule, right? C-A-S-T. Just tangent is positive. Here is going to be negative. Tan theta plus pi, what do you think? Is positive or negative?
Positive.
Positive, because the tan in that quadrant gonna be positive. Now, this transformation could be by any multiple of the pi. Let's say, let's do sine of pi minus theta, cosine of pi minus theta, and tan of pi minus theta. So the transformation by pi, 2 pi, or 3 pi, the trigonometric ratio not changing. If this is sine, remains sine of that angle. But let's see, how do we deal with this? If I draw a unit circle here, pi is here, right? Pi minus theta is this line, true?
Yeah.
So you are in the second quadrant. According to the second, just the sign in the second quadrant is positive. So this is equal to sine theta. Do you think it's positive or negative here?
Positive.
Positive. And cosine pi minus theta is cosine theta. Negative or positive?
Positive.
Negative. Just
Ah.
here in this quadrant, see, we are here. Just sine is positive. And here is tan theta, positive or negative?
Positive.
So just sine is positive. Here we are in this quadrant, right? See, we are in a second quadrant. It's 1, 2, 3, 4. We are in a second quadrant. It's gonna be negative. S here means just sine is positive. The other ratio is negative. So another one that I could do is sine of 2 pi minus theta, cosine of 2 pi minus theta, tan of 2 pi minus theta. Which quadrant I am for this one? Which quadrant do you think we are? So 2 pi is here. 2 pi minus theta would be in quadrant 1, 2, 3, or 4. So here 2 pi minus theta, you have to go back by theta. You're here. 2 pi, then you go back. Forward is positive, backward, like if you go counterclockwise, is positive, but clockwise is negative. So 2 pi is 360 is here. So you minus theta, you have to go this way. So here is going to be sine theta, positive or negative? So since in this quadrant, cosine is positive, right? The rest of that is negative. So just cosine is positive. So it's going to be negative. Here, cosine 2 pi minus theta is cosine theta. Again, in this quadrant, just the cosine is positive. Here is equal to tan theta. Just the tan is positive. Just prepare. I will do a quiz next time. You need to answer my questions for this one. Here is tan is negative because in this quadrant, just the cosine is positive. You can have 3 pi. Good. You have to treat it the same way. Can you take a screenshot of that so I can go to the next one?
Yeah.
Good. Now, the next one, it will be similar, but your transformation is by 2 pi. Again, you have x and y here. This component gonna be your y. This component gonna be your x. This is theta. So from that, sine theta is x y over 1. Cosine theta is equal to x over 1, and tan theta is y over x. Now, if I do the transformation by pi over 2, so it'll be here. See, you just rotate it by pi over 2. And from here to here, if you rotate it, this side will be here. So this is your y now. And from here to here is your x. Of course, this is going to be your theta, right? But what would be this one that it makes with x-axis? Is going to be pi over 2 minus theta. Right? So yeah, it's just if from here to here is pi over 2 plus theta, is going to be that. Now, it's going to be pi over 2 plus theta. Now, let's just do the calculation, right? So I'm gonna do that here. Let's just do sine of pi over 2 plus theta. See, I'm just gonna make sure you guys know that from here to here is pi over, so from 0 to that line, the red line is pi over 2 plus theta. I want to see what is the sine of pi over 2 plus theta. Since in a red y, see, this is my now my x component, and now this is my y component. Since the x and y component is kind of reversed, the sine is turning to the cosine, and cosine turning to the sine. For this one, this is equal to what? Cosine of theta. But positive or negative, since according to the cast rule, putting the cast rule here, C A S T. So since you're in this quadrant, sine in this quadrant is what? Positive. So this is going to be positive here. Cosine pi over 2 plus theta equal to sine theta, but positive or negative? Here, just sine is positive. Of course, this one should be negative. Tan of pi over 2 plus theta. Tan is turning to cotan. So positive, negative, of course, negative, because in this quadrant, just the sign is positive. So we have other multiple of the pi over 2, like what? Like 3 pi over 2. See, sine of 3 pi over 2. 3 pi over 2 is 270 degrees. Minus theta. And I'm going to do cosine of 3 pi over 2 minus theta and tangent. 3 pi over 2 minus theta. Okay, 3 pi over 2, see, this is 3 pi over 2, this line. Minus theta, you have to go back. So it's going to be in this quadrant. So of course, this cast through, just tangent here is positive. The sine turn to cosine. Cosine turn to sine. Tangent turn to cotangent, but positive or negative. Here just tangent is positive, right? So you just put it positive for tangent. The rest of that need to be negative. Another one that we could have is sine of 3 pi over 2 plus theta. Cosine of the 3 pi over 2 plus theta. Tan of 3 pi over 2 plus theta. Now, first, what quadrant we are here? First thing you need to know is what quadrant. Again, the unit circle. Here is 3 pi over 2 plus, this is 3 pi over 2 plus theta, plus an angle. You're here. Cast through. See, just the cosine is positive. So sine turn to cosine. Cosine turn to sine. Tan turn to cotan. But positive or negative? Just cosine is positive, right? So just cosine is positive. The rest of that is negative. Again, cast through. Just the cosine is positive. Okay, can you take a screenshot? And if you have any question, please ask. Let me know.
Yeah, I got the screenshot.
You got it? Okay, perfect. So this is the rules that you don't need to memorize, right? You just need to know the rules and apply it for this transformation. Let's say I tell you cosine pi over 2 minus x. You simply make this circle. Pi over 2 is here. Minus x means you have to go back. You're here. Since this is a pi over 2, cosine turn to sine. And in this quadrant, everything is positive. So it's going to be positive sine here. The same thing. You have this side, you can get the other side. You don't need to memorize that. Just need to know the rule. So this is transformation for that. So we have two examples. We're using this rule to do these examples. So given that the cosecant of the pi over 4 is a square root of 2, use an equivalent trigonometric expression to show that secant of 3 pi over 4 is negative square root of 2. First, we want to show this, right? I have to start with this. Secant of 3 pi over 4 because the secant is connected to the cosecant, perhaps the transformation is pi over 4, by pi over 2. So 3 pi over 4, I minus it by pi over 2. See what is the difference between these two. If you multiply this one by 2, the numerator by 2 and denominator by, they have the same denominator. So 3 minus 2 is pi. Is pi over 4. Therefore, 3 pi over 4 is equal to what? See, bring the pi over 2 to the other side. It's going to be pi over 4 plus what? Plus pi over 2. So instead of that, secant 3 pi over 4, I can write it as pi over 2 plus pi over 4. See, this is pi over 2 plus theta, true? This is your theta. So therefore, this becomes cosecant. Since the transformation is by pi over 2, the secant turn to cosecant. It's gonna be cosecant of that angle, which is pi over 4. But positive or negative? Okay, pi over 2 plus theta. This is pi over 2 and plus theta is here. In this quadrant, just the sign is positive, right? Secant is 1 over cosine. Of course, cosine is negative here. So that's why you have to put a negative number here. Since this is given, this is gonna be what? Negative cosecant of pi over 4 is a square root of 2. And instead of that, you put a square root of 2. Okay? So this is proven. Can you take a screenshot? I'm going to just do the last example. Now looking at this, cotan of 13 pi over 14 equal to negative tan z is given to you. First express. Okay, we want to find what is the angle of this z, right? Because the tan is converted to the cotan, the transformation might be by pi over 2. That's why I say pi over 2 minus 13 pi over 14. I need to take a common denominator. How? Multiply this one by 7. Multiply this one by 7. They have a same denominator, which is 14. 7 minus 13 is what? 6 pi. If I rearrange that, see 13 pi over 14 to the other side is equal to 6 pi over 14 to the other side. It becomes pi over 2 minus, no, and instead of 6 pi over 14, I can put what? Divide both side by numerator and denominator by 2. It's going to be 3 pi over 7. Pi over 2 minus 3 pi over 7. Now, I just started with this. Cotan of 13 pi over 14. Instead of the 13 pi over 14, I can put pi over 2 minus 3 pi over 7. So cotan will turn to tan, right? Because this is pi over 2 minus theta. This is my theta. Tan theta, tan of 3 pi over 7. But positive or negative, just need to look for it. Let me see if I did it right. So guys, this is to this side and this one. Oh, this is negative, my bad. Yeah. And so this turned to positive. So this is gonna be pi over 2 plus a theta. So it's here. Tan in this quadrant is negative. See, cotan 13 pi over 14 is equal to negative tan of 3 pi over 7. Means z is what? Z is 3 pi over 7, okay? Can you take a screenshot, please? Let me know.
Yeah, I got that.
You got it? Okay. Now, this is let me just go to the worksheet, the question you need to do. So question 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10, the first 10 questions. I'm expecting you to do it. And next time I will be giving you, all of you, a quiz, right? So be prepared quiz on that.